Hey everyone, Mr. Fransky here again. Today we're going to talk about the equations of translated ellipses. So we're going to take our ellipse, we're going to move it left, right, up, down, just like we did with our parabolas for the second time around. So we're going to be able to graph and find the equations of translated ellipses. Vocabulary is the same as last time. Ellipse, foci, vertices, major, minor axis, and completing the square. So completing the square is added this time because we're going to kind of see what we did, just like what we did with the parabolas, where we had to complete the square and be able to find the equation in standard form. So we're going to start off with just some regular ellipses like we had in the last video. If you feel like you have this down, you can skip this part for sure. Probably take about 10 minutes, so you might want to. But I'm just going to run through these problems, so if you want to try them, you can pause the video. If you feel like you don't need the practice, then you can just zoom ahead until we get to the part where it says, let's move them. All right, let's see how you did. So I'm going to run through these. I've got them all set up. So the first one, we got x squared over 9 plus y squared equals 1. So a is easy here, right? A is 3. The b value is kind of weird, but technically this is divided by 1, right? So our b value is 1, because that's 1 squared. So this is going to be a left and right ellipse. So we go left 3, right 3, and we go up 1 and down 1. So here's our ellipse, going to be long and narrow, like this. Okay, no extra points for good artwork. And so our c value now, so c squared is going to be, in this case, 9 minus 1, which is 8. So c is the square root of 8. That's something between 2 and 3, and pretty close to 3, actually. So it's going to be like out here and out here. So our foci happen at plus and minus root 8, comma 0. Okay. Major axis is the horizontal, and it looks like it has a length of 6. Minor axis has a length of 2. Nothing too exciting, though. Just an ellipse. All right, next up we got 25x squared plus 4y squared equals 100. So if we divide both sides by 100 to put it into standard form, we got x squared over 4 plus y squared over 25 is equal to 1. So a is 2, 2 squared is 4, b is 5, because 5 squared is 25. So we're going to go left 2, right 2, up and down 5. Creates our little ellipse like this. Okay, c squared in this case, bigger minus smaller, so it's 25 minus 4, which is 21. So c is the square root of 21. That's between 4 and 5, so it's going to be pretty close to the edges. About there, about there. Okay, so our foci, in this case, happen at 0 plus and minus root 21. Major axis has a length of 10, minor axis has a length of 4. Vertical ellipse. Vertices happen at 0 plus and minus 5, right, up and down. Okay, next up we got an ellipse with foci at -8 and +8, and vertices at -9, 0, and +9, 0. So let's see if we can figure this out. So pretty far out to the left and right. 1, 2, 3, 4, 5, 6, 7, 8. There's a focus. 9 is where the vertex is. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 8 is the focus, 9 is the vertex. So right now we know that A is 9, right? Because we go left 9 and right 9 to get out to those vertices. We also know that C is 8. So we're going to use our formula. 8 squared is going to be absolute a squared minus b squared. So that's going to be, in this case, the a is bigger. So that's going to be 8 squared, which is 64, is equal to 81 minus b squared. So if we add b squared, subtract 64, it looks like b squared is 17. Now we could take the square root to actually find that, but if we just want the equation, it's going to be x squared over a squared, which is 81. That's our a squared. And then plus y squared over b squared, which we know is 17, is equal to 1. Let's actually figure out b, though. So b will be the square root of 17. That's somewhere, that's really close to 4, right? Because 4 squared is 16. So we go close to 1, 2, 3, 4, go up to 5, but it's going to be really close to 4. 1, 2, 3, 4 down, really close to 4. So we have an ellipse that looks like this. Oh, go to the vertex, not to the focus. And then, oh, up here. There we go. Okay. There we go. So something like that. Not the most beautiful ellipse, but it's fine. All right, what's next? So, just going to do some completing the square here for good measure, because this is something we're going to be working on today. So I'm going to do this a little bit different than we've seen before, but still has the same principles. So the first one, if we take out the 4, we have 4 times x squared plus 2x. Okay, so if we complete the square there, maybe a little more space for it maybe. So we complete the square here, we're going to have a plus 1 on the inside. And I'm just going to leave it like that. I'm going to do 4 times x plus 1 squared. Because that's kind of how we're going to work with it today. This next one, I pull out a 9. That's with x squared minus 8x. Complete the square there, divide it by 2 and square it. That's -4 squared plus 16. So I'm going to leave it like that again. 9 times x minus 4 quantity squared. So you could bring the 9 back in, right? And then you could factor. I'm going to leave it on the outside. This guy, let's see. If we pull out a 25, we have x squared plus 4x. That would need a plus 4 because half of 4 is 2. Squared is 4. And so that would be 25 times x minus, or x plus, 2 squared. All right. I said 10 minutes. It only took about 5.5. Not bad. Okay. So now let's see what's going to happen. We're going to move these ellipses. So if the center is at 0, 0, we've seen this equation a lot now. X squared over a squared plus y squared over b squared equals 1. If we move the center to hk, just like we did with a parabola, it's going to move right k units, or right h units, and left, or up or down k units, right? So x minus h squared plus y minus k squared is over a squared and b squared, still just equal to 1. So this guy, the relationship we had, so let's say it's a is bigger. So we have a over here, negative a over here. Right, we go up to b and down to b. It doesn't matter if it's positive or if it's up and down or side to side, right? This is always true. B goes up and down, a goes left and right. And then the c values, right? The c tells you how far the focus is from the middle, and c squared has this relationship absolute a squared minus b squared. So this guy pretty much is going to be the same, right? Only difference is that now we have it over here centered at some hk. So the weird thing about this is everything comes from the center. So let's say we have like roughly the same ellipse. Okay, something like this. So the distance to the outside is still a. So from the center to the outside is still a. From the center to the top or to the bottom is still b. And then if you figure out what your focus points are, they're still on the major axis. And the distance from the center to those focus points is still c. Okay, it's getting pretty busy here, but everything is the same. It's just that your center now is hk instead of 0, 0. So everything is counted from the center. That might be worth writing down. Count from the center. Okay, so you're never, once again, I wouldn't memorize any formulas or anything. You're just going to be counting everything from that center, that hk. All right, computer, we can move on now. All right, so find the center, vertices, and foci of this guy. So this is written in standard form already. So it looks like our center is going to be at negative 2, 5, right? Because it's x plus 2, so that's a negative 2, and then y minus 5, so that's a positive 5. So that's our center, so let's do that. So negative 2, 5, that's going to be in the second quadrant. Once again, we're in the second quadrant. I must like that a lot. 1, 2, 3, 4, 5. There's our center. Okay, we can label it C or something if you want to, but I'm just going to put a plot there. Now, A value here, it looks like is 3. B value looks like it's 7, because it's square root of 9, square root of 49. So that just means I go left and right 3. So you just count from the center. 1, 2, 3. Looks like I have to go 1 over to the right. And then we go 1, 2, 3 to the left, right there. So minor axis there because it's smaller than the B. Then we go up and down 7. I'm going to make it small. 1, 2, 3, 4, 5, 6, 7 up. And then 1, 2, 3, 4, 5. We got to go down to negative 2, 7 down. So our vertices are at negative 2, negative 2. And at negative 2, let's see, we were at 5 here. We had 7 more. It's 12. So negative 2, 12. So that should make sense. It should be 14 in between. Yep, because that's 2b. Now we just connect our dots. Right, and my top's a little shorter because I didn't quite do it to scale, right? But that's our ellipse. That's all there is to it. Okay, so we found the center. Center was at negative 2, 5. We found the vertices. Now we got to find the foci. So we still have this relationship. It's still c squared is equal to absolute a squared minus b squared. It's just that now it's going to be like out in no man's land. It's not on an axis anymore, right? But it's still the same distance from the center out to each focus. So in this case, c squared, we just look at the bigger one, right? 49 minus 9, that's 40. So if c squared is 40, c is root 40. Oh, come on. Square root of 40. So if root 40, that's going to be between 6 and 7. Right? Because 6 squared is 36, 7 squared is 49. So we're going to go up and down between 6 and 7. 7 is all the way, so it's going to be pretty close to the edges. This happens a lot when you use whole numbers. Okay? So our foci, now the coordinates for the foci can be kind of tough because you're starting from negative 2, 5, and you're going up root 40 and down root 40. So watch this. It's super easy. All you do is you say the x coordinate is for sure still negative 2. The y coordinate is going to be 5 plus root 40 or 5 minus root 40. Negative 2, 5 minus root 40. And again, if you want to do this, negative 2 plus or minus, 5 plus or minus root 40, you can do that. So we really had this before. It's just that the vertices were always counted from 0, so we didn't have this extra number here, right? But that's where our foci are. Cool. All right, let's try something else. Find the standard form equation for the ellipse with vertices 2, -2, -1, and 8, -1 with minor axis length 8. Well, let's draw a picture, because I sure think that's going to make things easier. So let's see, we need -2, -1, and we need 8, -1. So right away, I think we can find our center, right? How far away are my vertices, right? These are the vertices at the end of the major axes. I'll put V's there so we know what they are. So let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in between. So the center should happen 5, like exactly halfway in between them. So 5 over. 1, 2, 3, 4, 5. So it looks like our center is at 3, -1. No math, right? All I did was find the middle. So that's our center. Now they tell us the minor axis has length 8. Well, let's see. A here is left and right, so that's 5. The minor axis is length 8, so that's going to be up and down, right? Because we know that these are vertices, so those have to be the ends of the major axis. So the minor axis has length 8, so I'm going to go up 4, and I'm going to go down 4. So I'm going to go up 1, 2, 3, 4, right there, and down 1, 2, 3, 4, right there. Now we can connect the dots, make our ellipse. Okay, so that means our B value is 4. So we got A, we've got B. We can now find C, right? C squared this is the center, not C value. I swear, this is so annoying. All right, so this is the center. And we know C squared is going to be, in this case, 25 minus 16, which is 9. Hey, C is 3. So we're going to go 3 to the right, 1, 2, 3, and 3 to the left, 1, 2, 3. It's right on the axis. So our foci happen at 1, 2, 3, 4, 5, 6, -1, and 0, -1. That's all there is to it. Major axis horizontal has a length of 10. Minor axis has a length of 8. They told us that. Not too bad. Okay, so the last thing we're going to do with ellipses is completing the square to be able to put them into standard form. So right now we have the x's all over the place, got the y's all over the place. We're going to group them together. So what I'm going to do is I'm going to move the constant to the other side, and I'm going to leave everything else over here. But I'm going to group them, right? So we're going to have 16x squared minus 32x plus 9y squared plus 54y is equal to 47. Hopefully we're going to be able to turn that into a 1 at some point. So now I'm going to complete the square separately on the x's and the y's. Okay, so first thing I'm going to do is I'm going to pull the 16 out of here. So I have 16 times x squared minus 2 plus 9 times y squared plus 6, right, equal to 47. Now I should have given myself some more room here because this is the part where we're going to complete the square. So some more room there, some more room here, equal to 47. So let's see what we need. X squared minus 2 divided by 2 is -1, squared is positive 1. So put the 1 there. Now the weird thing is, what did I really add here? I added a 1, but I really added 16, right? Because if you distributed this back in, you would have 16. So that means I have to add 16 on the right. Now, let's look at this one. 6 divided by 2 is 3. Squared is 9. So plus 9 there. 9 times 9, 81. So let's see what we got. We can factor now, right? This should be x minus 1 squared. This should be y plus 3 squared. And it's all equal to, let's see, 47 and 16 are 63. 63 plus 81 is 144, which happens to be 16 times 9. Great. So we divide both sides by 144. So we have x minus 1 squared divided by 9 plus y plus 3 squared divided by 16 equal to 1. And there's your equation, your standard form. And then we could graph it, right? The center would be at 1, -3. A is 3. B is 4. Not too bad. All right, let's try this last one. Why don't you try it? Pause the video and come back. See what you get. All right, let's see how you did. So I'm going to group the x's. So we got x squared plus 6x. And then I'm going to pull the 4 out of this part. So I have 4 times y squared minus 12y. Leave a blank here because we're going to complete the square. Move the 149 to the other side, so I have -149. All right, this needs a 9. There's nothing in front, so I'm just adding 9. So now I have -140. This guy, 12 divided by 2 is 6 squared is 36. I have plus 36 here. Oops. Okay. Now we factor. Sorry, what did I add? 4 times 36 is 120, and 24, it's 144. Okay. So this guy is x plus 3 quantity squared. Then we have plus 4 times, let's see, this would be y minus 6 squared, equal to Let's see, negative 140 is positive 4. Yeah. Now we divide both sides by 4. So we got x plus 3 cubed over 4 plus y minus 6 squared. Sorry, so they go squared. I don't know where the cube came from. Equal to 4 over 4, which is 1. So a is 2. What's b? Well, this is divided by 1 technically, right? So b is 1. And then we could find c by doing the square root stuff, right? But I'm not going to bother with it right now. Not too bad. And that's it. That's all I got for you. Love you guys. That's why I'm here. Have a great day. Make sure you come back and watch the ellipse proof video if you're interested. It's pretty cool. See you later.